Hello all. Today let we learn about canonical and standard forms of representation of a Boolean function. Now, these representations are used to minimize your Boolean functions using your K-map method or using your Boolean laws and theorems. Basically, our Boolean functions may have been represented in several ways. They are sum of product forms, product of sum form, truth table form, standard sum of product form, standard product of sum form. We also have Venn diagram form. We also have K-map method to represent your Boolean function. These are some of the ways to represent your Boolean function, but say the familiar ones which are we are going to learn about these 5 types in this session. So first way of representation is sum of product form. So you can represent each Boolean function by its sum of product form, which is the abbreviated form of your SOP. In a short form, you can call that as a SOP form. So this can be obtained by taking your summation of all the product terms. So now, we have given an example here. So a function with a 3 variable, so f of ABC in summation of product form is, so we are ORing the product terms where the product terms can contain the variables which are not necessarily all the variables. So in the first term of product we only have A and B. The second term we only have BC. B doesn't have your A variable. And in that each product term your variables are may complemented or uncomplemented variable. So this is the one way of representing your Boolean expression using sum of product. So second way of representing is product of sum form. So this can be abbreviated form of your POS. So in a short notation, we can represent product of sum as POS simple form. So POS form. So now we can obtain here the representation of Boolean function in the form of ANDing of your sum terms. Now here f of ABC is an example I have taken. So with the 3 variable. Now the sum terms are ANDed or we have taken a product of these sum terms. And when we observe your variables which are inside the sum terms, so there is no rule that each sum term should contain all the variables in your POS form. So hence the first sum term can contain only the 2 variables AB. The second sum term contains only the 2 variables of BC. Now in this form, so here the variables may complemented or uncomplemented ones. First sum term should contain here that it contain that both variables are complemented one. In the second sum term, both variables are in uncomplemented nature. So now let we observe the third way of representing your function, which is using your truth table form. So in this form of representation, so we are going to represent or we are going to have all possible input combinations where each variable is assigned with the binary value. So hence here I have taken the 3 variables and substituted the possible values of your binary started with the 0, 0 to 1, 1. For each possible combination there was a corresponding variable function. So function values of zeros to ones. So now for each possible combination there is a particular functional value. So here we have taken an example of f1. For 0 0 it is 0, 0 0 1 your functional value is 1. For 0 1 0 it will be 0, 0 1 1 it will be 0, 1 0 0 it will be 1, 1 0 1 it will be 0, 1 1 0 it will be 0. For 1 1 it is 1. As we discussed in other logical operation, if we have 3 variables, so here I have mentioned only one functional value, but the possible number of logical functions you can implement with 3 input variables is 256 number of functions. Out of that 256 number of functions, we only have taken one of its function which is f1. Next, the fourth way of representing your Boolean function is standard sum of product form. So in a short form, we can call the standard sum of product form as SSOP, or we can also call this as a sum of minterms. So now it can be formed by ORing your minterms of the functions for which the output is true value, where the minterm is a product term whose functional value is defined with a logical one. So here each product term in your summation of products contain all the variables where those variables are in the nature of complemented or uncomplemented form. So this is the first way of representing your function with the three variables. So using your complemented and uncomplemented variables. Next, the second, you can also represent your function with a symbolized minterms with a small letter m, and m1, so which denotes, so it's a function of three variables, so possible minterms available is 8. So now based on our function only we have here the four minterms are available. So in order to differentiate those four possible minterms, we used that index as a number in your minterm values. So M1 represent for 001 your functional value, that product term, the functional value is 1. For 010 it will be 1. For 100 it will be 1. For 110 it will be 1. So hence here, so this is the second way of representation with your, which is in the form of standard SOP. So using the minterms with their indexing or using the variables, we could represent your given function in the nature of SSOP. Now, so there is another way, the third way of representing your function which is in SSOP or canonical expression is using your summation symbol with a sigma, and then writing your minterms inside a parenthesis which could give you the output value true. So now, so we were going to represent the minterms are the product terms, so which are having a true value of output with the minimum number of combination of inputs. So possible inputs for a 3-input variable is total is 8. So it will started with the designation of M0 to M7. So where M0 is a product term. So here the assigned values on X, Y, Z are 0, 0. Hence as a product term, if I mention that X, Y and Z values, so I have to represent your zeros as complemented variables and ones if I assign on variable without complement. So first combination is all zeros. So hence in the product term, I need to represent those variables with a complemented ones. So X bar, Y bar, Z bar. Next X, Y, Z, X bar, Y bar, Z, which is 0, 0, 1. So 0, 1, 0 as a product term, it is represented as X bar, Y, Z bar. Now the designation which I am going to use for min term here, it is M2 and 3, 0, 1, 1. So as here X is 0, so hence X is represented with complement, Y and Z are 1, 1. So in that product term, Y and Z are represented without complement, and the designation which I am going to use is M3. So it's a minterm 3. So where the decimal code is represented as M3 denotes one of the minterm of your 3-input variable. Now, so in our example, I have given this is my function which I am going to represent in the form of standard SOP. So in order to represent the function in standard SOP, we have to identify the functional values 1 for which product term it is. So that decimal codes of main terms must be represented as a infix. So now for 001 the decimal code is M1. So your designation is minterm 1 whose functional value is 1. So we are going to represent that as a product term or summation of your product term. So now we have we found another one for 010. So it is also one of the minterm which is M2. Next M4 functional value is also 1. So M6 functional value is also 1 here. Hence the function is having 4 minterms the addition of minterms or the addition of your product term or summation of your product term. So now we can also use the summation symbol. So whose minterms we are going to add, that must be represented inside the parenthesis. We are adding the minterm 1, minterm 2, minterm 4, minterm 6. Hence we represented that decimal codes which is inside the parenthesis with a sigma symbol. Sigma represents summation of your minterm whose decimal codes are 1, 2, 4, 6. This is another way of your representing your SSOP. So now in order to obtain your minimal SOP form, we are going to use this Boolean loss and Karnaugh map method. Upon using those Karnaugh map and your Boolean algebraic, so your SSOP functions will be converted into minimal SOP, and these minimal SOPs are preferred for realizing your Boolean functions with the minimum number of gates as well as with the minimum number of input lines. So this is one of a non-canonical form of representation of your SOP expression. Now I used here a K-map method in order to get your minimal SOP form. So now upon grouping your minterms, so we could have your minimal expression which is f is equal to a bar b or of b bar c. How we are getting this final minimal expression, that we're going to learn in your unit 3. Now so unit standard POS form. So here in standard POS form, so this is also called as a canonical product of sum form. We are going to form this representation of Boolean function by adding your maxterms of the given function whose functional values are false. So this is also known as product of maxterms. Maxterms are nothing but your sum terms. So now these sum terms are multiplied, or we have to take the product of your all the sum terms whose functional values are 0, and each sum term can contain the variables which are in the nature of complemented or uncomplemented form. So now the way of representing your f of abc using your variables is, so we have to represent all the max terms which are as sum terms, so using our variables. So here I have mentioned a or of b or of c is one of the max term, where here the variables are represented without complement. So the functional value, so if you are assigning a 0 on your variables, so that if you are representing as a sum term, so it must be, your variables must be without complement. So a b c are uncomplemented variables. Their equivalent logical levels substituted are 0 on A, 0 on B, 0 on C. Hence the max term is M naught. Next, A bar or of B or of C, so is another max term. So where A value is logic 1. So hence we represented here a logical one. If you are substituting, the variables are represented with complement. If you are substituting a variable with logical 0 in max term, that variables are represented without complement as an uncomplemented variable. So BC are uncomplemented variables. 1 or of 0 or of 0 is your M4 representation of max term. Next, a bar or of B bar or of C is M6 representation. A bar or of B bar or of C bar is M7. Next, here these canonical forms are represented with the product of max terms in order to represent that product. So we symbolize that with a pi symbol, and whose functional values are false or which will give you the 0 functional value must be represented inside the parenthesis. Now, so this is the way of representing your 3 variable inputs and their max term designations and their mean max terms with variables. So 0 0 is represent XOR of Y or of Z, 0 0 1 is XOR of Y or of Z bar, 1 1 is X bar or of Y bar or of Z. So using your pi m of 0 1 4 4 6 7, we also represent your max terms. Next, using K-map method, we are going to have your minimal expression. So this is the way of representing your Boolean function. Next class, we are going to learn about minimization techniques using K-map method. Thank you.